Assalamualaikum and hello. My name is Muhammad Syazwan Ikmal Muhammad Sabari and my supervisor Dr. Ruhizan Liza Ahmad Shauri. Today, I'm going to present my final year project, Robot Arm Design Imitating Human's Upper Arm with Gripper and Effector. Nowadays, the robotic industry has been very popular lately. Japan is one of the most famous nations with the robotic industry which is used for education, automotive industry, and research study. The robot is becoming an integral part of their global economy. New reports and stories have come out every day about the innovation in robotics that have been potential to change our life. Programming plays an important role to complete a specific task effectively. Every type of movement of the robot is controlled by programming. Besides that, different programs will give a different robot movement and interaction with the product. However, it is not just only happened at Japan. Malaysia is also a nation that has been expanded in the term of robot industry, which assists the employees to perform a specific task that costs time and money. The industrial robotics are capable of doing heavy lifting, assisting during the work, and even assemble the components at the right place, which also can operate for 24 hours. Robot is based on science, mathematics, technology, and principle of progress which help the human to perform a dirty, repetitive, dangerous, and impossible task. The main purpose of robot is assisting the human, and each type of the robot has its own application as it relies on the features and capabilities. Furthermore, robotic arm is a mechanical product where the sold rate is extremely high all over the world. Thousand kinds of arms are available within the market and developed by different companies. The function of robotic arm is not only for a normal purpose. It is only always used for specific purpose in industry where humans are not able to work with heat, polluted air zone, and heavy weightlifting. Other than that, robotic arm is also used for the top accuracy places where errors are not allowed. There are several types of robotic arm available in industry, such as Epson, Kuka, and Yaskawa. A prototype of 4 degree of freedom was constructed in the previous project, but the first joint of the design failed to work due to the heavy steel material of the spur gears, and that caused the misalignment of the gears, and also due to the mistake in the arrangement of the spur gears. In consequent study, an improvement was done by changing all the design and components of the robotic arm. However, the result produced vibration at the joint during rotation and due to unsuitable selection of the motor specification. Moreover, the counter could not calculate the encoder signal correctly. Thus, a new whole design of the robotic arms need to be revised and redesigned. The objective of this project was to construct the structure that imitate a human upper arm and to draw each component of the proposed structure in 3D using SolidWorks software. Next, methodology flow. The robot arm design imitating human upper arm with gripper and effector was implemented into two phases. The phase consists establishing the structure of the robot arm and designing phase. The workflow starts with the study of the structure of the robotic arm and determine the design requirement before we proceed with sketching the structure of the robotic arm. The works continue with the design process of the links and joint of the robotic arm by using SolidWorks software. And the work proceed with the analysis of the simulation of the robotic arm by simulation test. Next, the investigation of the robot structure. The structure was first decided based on the intended application. In this case, the robot is required to imitate the posture of a human upper arm when manipulating small things with their hands while not exceeding the 4 degree of freedom to reduce cost. However, the robot joint should be flexible to rotate in three-dimensional direction in the robot space. The 4 degree of freedom required for this design means that there are 4 joints that rotate around X, Y, and Z axis respectively. The design of robotic arm is focusing on the whole new design, where the previous mechanism was failed to work during the heavy steel material of the spur gears. This new design consists of 4 joints and they are fully actuated. Furthermore, the working range of the joints are slightly different where joint 1 and 3 can rotate for 360 degrees. However, joint 2 and 4 working range are limited for 180 only. As we can see that A as the origin and B, C, D and E are the centers of the mesh for link 1, 2, 3 and 4. In addition, T as an effector of the design is peripheral device that attached to a robot wrist and allowing the robot to interact with its task. The important part in this section is to know the axis for the base, which is easier to sketch the following axis to ensure each joint and link can rotate correctly. The dimension of each component needs to follow the actual components, which will need to install the components in the future. The location of link shaft must be located at the right point which hold the payload of the whole arm when performing the movement. The part section is used to draw the section arm in 3D which be able to sketch the component of the robotic arm. The user needs to repeat this process in order to create other components, and once all the components created with the right dimension, a mating process are required to ensure all the joints of the robotic arm can be assembled into a completely new design of robot arm. The assembly section can gather all the parts created and assemble them at the right position to complete a robotic arm. The simulation also can be performed in this section when all the links and joints are assembled with the base to test its movement. In order to test its movement, all joints and links will rotate and the movement of each link and joints in the rationale of X, Y, and Z axis will be observed. The purpose of this simulation test is to ensuring the design is confirmed. In case where the result does not fulfill the design requirement, redesign of the affected part will be carried out until it fulfills the design requirement. Once the simulation is satisfied, the arm design ready to be presented. Simulating the new robotic arm with the current design implemented is the next method for this project. The simulation process by testing the rotation for axis X, Y, and Z, and also testing the movement of all links and joints by using a SolidWorks software. If the dimensional is all met, the robot arm design will move without error. The importance of the simulation is to ensure the design is confirmed before being presented. Otherwise, the link that having the error need to be redesigned and tested again until it meets the desired dimension. From here, we can see the fully method of the robotic arm design. In this case, we can observe that the robot arm moving from its initial position by rotating the link 1 on the x-axis. However, different with link 2 and link 3 because it is moving by rotating on y and z axis. Nevertheless, the link 4 is also rotating on x-axis just same like link 1. So, the working range for joint 1 and joint 3 are 360 degree. However, for joint 2 and 4 are limit until 180 degree only. As conclusion, it is important to correct the structure of the robot arm and the rotation axis of the joint and links to ensure the robot arm to imitate the human upper arm as mentioned in the object before. From this project, we can see that links 1 and 4 are rotate on x-axis while link 2 and link 3 are rotate on y-axis and z-axis. Furthermore, the working range for joint 1 and 3 is 360. However, the joint 2 and 4 are limited until 180 degree only. In the future work, this design can be used for improvement for the 4 degree of freedom robot arm and can be assembled with the 3-finger robot hand to make a real industry robot arm that imitate a human upper arm.